Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, we're going to be taking a look at sequences, which is a topic that frequently appears on the Arithmetic Reasoning subtest of the Armed Services Vocational Aptitude Battery. As you can see, there's three main objectives for today's video. First, we want to be able to identify arithmetic sequences. And in addition, we want to be able to find the nth term as well as the sum of the terms in arithmetic sequences. Second, we want to be able to identify geometric sequences. And likewise, we want to be able to find the nth term as well as the sum of the terms in geometric sequences. And then finally, we're going to take a look at sequences that are neither geometric nor arithmetic. And for those types of sequences, the only thing we're concerned with is being able to find the next term in the sequence. So as a few reminders, you're not allowed to use a reference sheet or a calculator on the ASVAB. And so in light of that, you're going to have to do all the arithmetic that you see in today's video by hand, as well as commit some of the formulas that you see in today's video to memory. In order to get the most out of today's video, I strongly encourage you to make an effort to work out as many of the practice problems as you see as possible. That is, once I read a question, pause the video, attempt to work out the question on your own scratch paper, and then resume playing the video to see if you and I came up with the same solution. So all those things being said, let's go ahead and get started with today's video. To start today's video, we're going to compare and contrast arithmetic and geometric sequences. And let's do that by first asking ourselves the following question: what is a sequence? A sequence of numbers is a list in which ordering may or may not follow some rule. So as you can imagine, there's more than two types of sequences, but the main types of sequences that you encounter are called arithmetic and geometric sequences. An arithmetic sequence, as we can see, is a sequence in which each term is equal to the previous term plus a constant. And this constant is referred to as the common difference. If we look at this example right here, we can see that we have a sequence, which is just this list of numbers. And in order to go from -6 to 1, we add 7. To go from 1 to 8, we add 7. To go from 8 to 15, we add 7. And to go from 15 to 22, we add 7. As we can see, this common difference is the same between each pair of numbers. And so it is a constant, and that would make this an arithmetic sequence. On the other hand, geometric sequence is a sequence in which each term is equal to the previous term multiplied by a constant, and this constant is called the common ratio. And as we can see in this example, we have a list of numbers that go from 2 to 32, and to go from 2 to 4, we have to multiply by 2. To go from 4 to 8, we multiply by 2. To go from 8 to 16, we multiply by 2. And to go from 16 to 32, we multiply by 2. In light of the fact that we're multiplying each number by a constant to get to the next number in the sequence, we know this is a geometric sequence. Okay, so in short, that's the definition of sequence, arithmetic sequence, and geometric sequence. Now let's take an in-depth look at arithmetic sequences. All right, so let's go ahead and take a closer look at arithmetic sequences. And as you may recall, our objectives are to find any term in an arithmetic sequence, as well as find the sum of all the terms in an arithmetic sequence. In order to find any term in an arithmetic sequence, we use this formula, that is a to the n equals a to the 1 plus d times n minus 1. And as we can see, a to the n refers to the nth term of the sequence you're trying to find. So in other words, if I asked you to find the 9th term in this sequence, that would be a to the 9. A to the 1 is simply the first term in the sequence. So if we take a look over here real quickly, we can see we have a sequence of terms from 9 to 24. 9 would be the first term in this sequence. D, of course, is the difference between consecutive terms. And as we know about arithmetic sequences, the difference is going to be a constant. That is, it's going to be the same between all the terms in the sequence. And finally, N is the position number. That is, if I asked you to find the 9th term in a sequence, that would be a to the n, which is a to the 9. And then n, as you can see, would be the same as 9. By identifying all those things and plugging them into this formula, you can find any term in an arithmetic sequence. All right, so let's say you wanted to find the sum of all the terms in an arithmetic sequence. You can do so using this formula, that is s to the n equals n times a1 plus an divided by 2. So for example, if I wanted you to find the sum of the first 10 terms in a sequence, that would be s to the 10 equals, again, n is 10, so that would be 10 times a to the 1 plus a to the 10 all over 2, okay? So with those formulas in mind, let's go ahead and look at an example so we can apply them. All right, so for example 1, you can see it says, given the following arithmetic sequence, find the next term in the sequence, the 10th term in the sequence, and the sum of all the terms between the first term and 10th term. So in order to answer this question, we're going to have to start by identifying what we have. Let's go ahead and start labeling the terms in the sequence. The first term, of course, is a to the 1. That would make this a to the 2, a to the 3, and a to the 4th. To find the next term in the sequence, that would be the same as finding a to the 5. And then finally, to find the 10th term in the sequence, that would be a to the 10th. Since this is an arithmetic sequence, we know that there's going to be a common difference between consecutive terms in this sequence, and we know that common difference is going to be the same or constant between all consecutive pairs. That is, to go from 19 to 14 is going to be the same as going from 14 to 19 and going from 19 to 24. To go from 19 to 14, you can see that we have to add 5. To go from 14 to 19, we have to add 5. And to go from 19 to 24, we have to add 5. Therefore, we know the difference in this case is going to be 5. With all these things identified, we can now find the next term in this sequence, which is a to the 5, as well as the 10th term in this sequence. And moreover, we can quickly find any term in this sequence that we wanted. If they said find the 1000th term in this sequence, we can do it. And again, we use this formula to figure that out. A to the n equals a to the 1 plus d times n minus 1. In this case, we want to find a to the 5. So that's going to be a to the 5 equals a to the 1. A to the 1, as we identified earlier, is 9 plus d. D is 5. N minus 1. Again, n is 5, so this is going to be 5 minus 1. Let's go ahead and work this out. Again, this is a to the 5, referring to the 5th term in this sequence, equals 9 plus 5 times 5 minus 1 is 4. So this is a to the 5th, or a to the 5 equals 9 plus 5 times 4 is 20. So this is a to the 5, or the 5th term in this sequence, equals 9 plus 20, or 29. So the next term in this sequence, in other words, is 29. Okay? Pretty straightforward, and honestly, you didn't need a formula to figure this one out. So on the ASVAB, if you're just asked to find the next term in the sequence, and you can identify the pattern that works, you do not need to use this formula whatsoever. Just go ahead and say, oh, it's plus 5, must be 29, and move on. That said, if you're doing really well on the ASVAB, you might be asked to find the 10th term in this sequence, in which case you might have to add 5, 5, 5, and 5 to get to the 10th term. Otherwise, you can make use of this formula to quickly solve what that 10th term is going to be. And again, we're going to use this formula, a to the n equals a to the 1 plus d times n minus 1. Okay, in this case, we're being asked to find the 10th term in this sequence. That's going to be a to the 10 equals a to the 1, which we identified as 9, plus d, which we identified as 5. N minus 1, again, n is 10, so this is 10 minus 1. Let's go ahead and work this out. A to the 10 equals 9 plus 5 times 10 minus 1 is 9. A to the 10 equals 9 plus 5 times 9 is 45. Let's work this out. A to the 10 equals 9 plus 5, which is 54. So the 10th term in this sequence would be 54. And again, the ASVAB can be tricky if you're doing well. Again, they might ask you to find the 20th term in this sequence, which would be a to the 20. And in that case, it'd be very tedious to keep adding 5. In fact, you would probably make a mistake, in which case you have to realize that you have to use this formula to figure it out. All right, so now let's work on finding the sum of all the terms between the first term and the 10th term. Again, that's given by this formula. S to the n equals n times a1 plus a to the n all over 2. All right, and in this case, we're being asked to find the sum of all 10 of the first 10 terms. So this is going to be s to the 10. And again, n is 10, so we can plug in 10 here. This is going to be a to the 1, which we identified as 9, plus a to the n. Again, in this case, a to the n is going to be a to the 10th, and we'll fill that in just a second. That's over 2. Let's go ahead and keep working this out. This is going to be 10 times 9 plus a to the 10. Thankfully, we figured that out already. Otherwise, we would have to use this formula again. So a to the 10 is the same as 54, which we got right here, all over 2. So this is s to the 10 equals 10 times 9 plus 54 is going to be 63 divided by 2. S to the 10 equals 10 times 63 is going to be 630. Again, that's going to be divided by 2. This one's pretty easy to do in our head. 630 divided by 2 is 6 divided by 2 is 3. 30 divided by 2 is 15. So as we can see, the sum of the first 10 terms in this sequence, arithmetic sequence, is going to be 315. Okay, so that was that one. All right, now that we've discussed arithmetic sequences, let's talk about geometric sequences. It's very similar, as you can imagine, and if you recall, our objectives for geometric sequences are to find any term in a geometric sequence, as well as to find the sum of the terms in a geometric sequence. Let me just stress this. Your odds of seeing a question about an arithmetic sequence are high, whereas your odds of seeing a question about a geometric sequence are low. I'm not saying not to commit this formula to memory. That said, if I were taking the test, this is not a formula I would stress too much about if I couldn't memorize it. So all of those things being said, let's go ahead and take a look at these two formulas. Again, to find any term or the nth term in a geometric sequence, we use this formula, a to the 1 times r to the n minus 1. A to the 1, of course, is the first term in the sequence. So if we look at this sequence here, a to the 1 would be 2. R is the common ratio, and that can be found by taking the second term in the sequence and dividing it by the first term in the sequence. And in geometric sequences, we know that that ratio is going to be a constant between all consecutive terms. And again, that's how you find any term in a geometric sequence. To find the sum of the terms in a geometric sequence, use this formula, a to the 1 times r to the n minus 1 over r minus 1. So let's go ahead and get some practice with this. Example 2, as you can see, says, given the following geometric sequence, find the next term in the sequence and find all of the terms between the first term and fifth term. So as we did with arithmetic sequences, let's start by identifying what we have. We have a to the 1, a to the 2, a to the 3, a to the 4th, or a to the 4, I shouldn't say 4th. The next term in this sequence would be a to the 5, as we can see. Let's identify our common ratio. Again, in geometric sequences, that's going to be a constant, and what that common ratio says is what takes me from 2 to 4 is the same number that will take me from 8 to 32, and that's going to be the same number that will take me from 32 to 128. To go from 2 to 4, we multiply by 4. To go from 8 to 32, we multiply by 4. And to go from 32 to 128, we multiply by 4. So we can see our common ratio in this case is going to be 4. With all those things identified, we can go ahead and find the fifth term in the sequence. Again, that's going to be a to the 5 equals a to the 1 times r to the n minus 1. Let's plug those things in. Again, this is a to the 5 equals a to the 1 is 2 times r. We identified that as 4. N minus 1. Again, we're trying to find the fifth term, so this is going to be 5 minus 1. Let's keep working this out. A to the 5 equals 2 times 4. 5 minus 1 is going to be 4. Okay, so let's work this out. We got to work out 4 times 4 times 4 times 4. So let's work that off to the side here. This is 4 times 4 times 4 times 4. 4 times 4 is 16. 16 times 4, let's work that out. If we can't do it in our head, 16 times 4 is 6 times 4 is 24. Carry your 2. 1 times 4 is 4, plus 2 is 6. So we can see that 16 times 4 is 64. Then we got to multiply that by 4 again. So that's going to be 64 times 4. 4 times 4 is 16, carry a 1. 6 times 4 is 24, plus 1 is 25. Okay, so we know this is a to the 5 equals 2 times 256. Now all we do is have to figure out what 2 times 256 is. Again, that's 256 times 2. 6 times 2 is 12, carry your 1. 5 times 2 is 10, plus 1 is 11. 2 times 2 is 4, and we got to carry our 1 there, so this is going to be 512. So a to the 5 equals 512. Again, many of you could have solved this sequence just by realizing that to get from 2 to 8 and 8 to 32 and so on, you're just multiplying by 4. Therefore, to get to the next term, we just multiply by 4. That said, if you were asked to find the 10th term in this sequence, you would have to use this formula to do the work. And similarly, if you were asked to find the sum of all these terms in this sequence, again, it would be more helpful to use this formula. All right, so now that we've found the fifth term in this sequence, let's go ahead and find the sum of the first through fifth terms in this sequence. And again, we can use this formula to do so. That's s to the n equals a to the 1 r to the n minus 1 over r minus 1. Again, we want to find the fifth term, so this is going to be s to the 5. A to the 1 is the first term, so that's going to be 2. R is 4. N is 5 minus 1 over R minus 1. Again, that's 4. So that's 4 minus 1 there. All right, let's work this out. This is 2. 4 to the 5th. This is another reason why geometric sequences aren't likely to show up on the ASVAB. 4 to the 5th is a lot of work to do. We already found 4 to the 4th right here. So 4 to the 4th, as we saw, was 256. So let's take 256 and multiply it by 4 now to get 4 to the 5th. 6 times 4 is 24. Carry your 2. 5 times 4 is 20, plus 2 is 22, carry your 2. 4 times 2 is 8, plus 2 is 10. So we can see that 4 to the 5th is 1024. That's minus 1 over 4 minus 1, which is 3. Let's keep working this out. S to the 5th equals 2 times 124 minus, or 1024 minus 1 is 1023 over 3. Let's work this out. 2 times 1023, that's 1023 times 2. 3 times 2 is 6. 2 times 2 is 4. 2 times 0 is 0. 2 times 1 is 2. Okay, so we can see that this is s to the 5th equals 2046 divided by 3. Let's go ahead and treat this fraction as long division. That is 2046 divided by 3. 3 doesn't go into 2. That said, 3 goes into 20. 3 goes into 26 times. Given that 3 times 6 is 18, subtract. 18 minus 20 is 2. Drop down this 4. Drop down this 6. Now this one's pretty easy to do. 3 goes into 24 8 times, and 3 goes into 6 2 times. So I know 82 times 3 is going to be 246 with no remainder. So in other words, 2046 divided by 3 is 682, which is the sum of the first 5 terms in that geometric sequence. All right, so now let's take a look at some sequences that are neither arithmetic nor geometric. And again, on the ASVAB, you're very likely to see an arithmetic sequence. You're very unlikely to see a geometric sequence. And you're guaranteed to see a question in which you have to find the next term in the sequence. In order to deal with these problems, you just have to identify the pattern that's occurring in the sequence. And again, if it's not arithmetic or geometric, we don't know if it's going to be a constant that's going to get us from 2 to 4 and 4 to 16. So let's take a look at this one. Some people are very good at recognizing these patterns, and other people have to play with the numbers a lot before they see the pattern. In this case, I know to go from 2 to 4, I have to multiply by 2. To go from 4 to 16, I have to multiply by 4. And to go from 16 to 96, I have to multiply by 6. Therefore, I know to go from 96 to this next term in this sequence, I'm going to have to multiply by 8. So that's going to be 96 times 8. 6 times 8 is 48, carry the 4. 9 times 8, of course, is 72. Plus 4 is 76. So we know that this next term is 768. And again, if this was a geometric or a arithmetic sequence, this would be a constant. That is, all these numbers would be the same. All right, let's look at another example. In this case, we have a sequence from 1 to 25. I know to go from 1 to 4, I have to add 3. To go from 4 to 9, I have to add 5. To go from 9 to 16, I have to add 7. And to go from 16 to 25, I have to add 9. So as we can see, we're adding consecutive odd numbers, 3, 5, 7, 9. So to go from 25 to the next term in this sequence, I'm going to add 11. So let's go ahead and do that. That's going to be 25 plus 11. 5 plus 1 is 6. 2 plus 1 is 3. So I know the next term in this sequence is 36. And finally, we have this sequence, 2, 9, 7, 14, 12, 19. Let's see, how can we go from 2 to 9? That's going to be plus 7. To go from 9 to 7, we subtract 2. To go from 7 to 14, we add 7. To go from 14 to 12, we subtract 2. To go from 12 to 19, we add 7. So I know to go from 19 to the next term in this sequence, we're going to subtract 2. 19 minus 2, of course, is 17. So I know the next term in this sequence is 17. Okay, so that's all I had to say about sequences. I hope you found this video helpful. Again, let me stress this. Absolutely memorize the formulas for finding the nth term in an arithmetic sequence, as well as how to find the sum of the terms in an arithmetic sequence. I showed you how to do that for geometric sequences, but again, that's very unlikely to appear on the ASVAB, so don't worry too much about that. And of course, realize that there are sequences that are neither arithmetic nor geometric. And for those types of sequences, you're just simply going to be asked to find the next term in those sequences, which is going to require you to figure out what patterns being used to go from term to term, and then apply that to find the next term. There's no real way I can show you how to do that without getting into a very long discussion about writing those algebraic expressions, and I'm sure none of you want that video. So all that said, again, I hope you found this video helpful. If you like the content I'm creating, please consider subscribing to my channel. But on that note, I'm going to go ahead and cut you loose.
こんにちは。